Okay, hey Brian, I'm very excited to talk about Nemotron. I think low-key one of the biggest evolving stories in 2025 of open models outside the obvious things in China that everybody talks about that gets a ton of attention. So thanks for coming on the pod.
Oh yeah, it's my honor.
So I wanted to start, some of these questions are honestly fulfilling my curiosity as a fan, as like, why does NVIDIA at a basic level release Nemotron as open models?
Well, we know that it's an opportunity for NVIDIA to grow our market whenever AI grows, and we know that um, uh, having access to open AI models is really important for a lot of developers and researchers that are trying to push AI forward. Um, we were really excited by efforts from some other companies around the industry to push openly developed AI forward. Meta did some amazing work, obviously, with Llama, and OpenAI released GPT OSS, which was exciting, and the Allen Institute, of course, has been really leading the charge for research, open research, and also things like the Marin project uh, and Open Athena. Like there's a bunch of things that we're always excited to see develop, and as we think about where AI is going to go, NVIDIA believes that AI is a form of infrastructure. Um, it's AI is a very useful technology when it's applied, but on its own, it's kind of a foundation, an infrastructure. We think that technology generally works better when there's openness to the infrastructure so that people can build things in different ways. You think about the way that the internet transformed every aspect of the world economy is pretty profound, and we're not done yet. But the way that, for example, retail uses the internet is different from the way that healthcare uses the internet. And the fact that different sectors of the economy were able to figure out how to incorporate the internet into the beating heart of their businesses in different ways was possible because the internet was built on open technologies that allowed people to try different things. And we think AI is going to evolve in a similar way, that organizations across every sector of the world economy are going to find new and surprising and fun and important things to do with AI. And they'll be able to do that better if they have the ability to customize AI and incorporate it directly into the work that they do. And by the way, this is not to detract from any of the more closed approaches to AI. The APIs that we see from a number of leading labs that are just extraordinary and have amazing capabilities. We're excited about those too. NVIDIA loves to support AI in all of its manifestations, but we feel like right now the sort of closed approaches to deploying AI are doing pretty well, but we could use some more energy in the openly developed AI ecosystem, and so that's why we've been putting more effort into it this past year.
Yeah, so I'm definitely going to dig into this a lot because I have seen this. We're sitting here recording in January 2026, which is in the midst of the rollout of these Nemotron 3 models. I think the Nano has released in the fall, which was probably one of the biggest splashes the org has made, and everybody's eagerly awaiting these super and ultra larger variants. And it's like, um, how far are you, how far are you willing to push this Nemotron platform? Like, is it just depending on the users and the uptake and the ecosystem? Like what is there a North Star in this? Where you hear a lot of, if you listen to a lot of other open labs, they're like, we want to build open AGI, which is like, I don't necessarily think grounded, but there's like a very unifying vision. Is there something that you try to set the tone for it that goes through the organization? I mean, AI too, it's like
My North Star
academics is
for
so,
Nemotron.
yeah, go ahead.
Oh, sorry. Go ahead.
I was just like going to compare to like AI2 where we can have such a like we have a very specific vision being so open that it's like I think like research is so needed and there's so little recipes to build on like with really credible research. So there's like a research infrastructure. And then when you have something like Llama, it was like built on Zuckerberg's vision and he changed his mind, which I actually thought his vision was excellent. The way he articulated the need for open models, and it kind of faded. So it's like, is there a way to set a vision for an org that like permeates everyone and is really compelling and exciting?
Right. Well, we build Nemotron for two main reasons. The first is because we need to for our main product line. So, what I mean by that? Well, accelerated computing, what NVIDIA does, we build fast computers, right? But the point of building fast computers is to help people do new things. And actually, uh, every fast computer is also a slow computer. You know, the observation that it would be nice if computers were faster and could do more things isn't new. That's been around since the beginning of computing. So what makes accelerated computing different from standard computing is that we're prioritizing, we're focusing, we're deciding we're going to accelerate this workload, this other workload, which is like 99% of all of the workloads, we're going to let somebody else do that, right? So like you do not buy NVIDIA systems to do any general purpose computation. You buy them for a purpose, right? Which is these days all about AI. But when you think about the workload, the compute workloads involved in AI, there's a lot of diversity, and there's a lot of really important parameters, hyperparameters, or algorithmic approaches that all have enormous impacts on the systems that we need to build for AI. So things like numeric precision, MOE architecture, which of course influences network design. We're dreaming about sparsity. We've had sparse neural network acceleration in the GPU since Ampere. I don't think that it's being used enough. So how do we figure out how to use that? These sorts of things have an enormous impact on the future of NVIDIA's main product line, and we have to understand the answers to those questions deeply ourselves in order to know what we're going to build. We can't just go to our customers and do a survey and say, hey, Meta, for example, since we were just talking about them, what would you like to see in a future product line from NVIDIA? Of course, Meta's always trying to help us as much as they can, but there's limits to what they can tell us because, a lot of the information that influences the design of these systems, it's very expensive to derive, and so therefore it's very closely held. And so we need to be able to understand these questions very deeply in order to understand what kinds of systems to build, in order to understand what we're accelerating in AI and what we're not going to worry about. And so that's kind of the first job for Nemotron models, is to make it possible for NVIDIA to continue to exist as a company. And I think it's important that the community knows that, because that's the reason why NVIDIA is making the investments in Nemotron, is because we believe it's essential for the future of our company. And so this isn't, although as much as it feels good to say, NVIDIA believes in openly developed AI because we're so charitable, but actually that's not the case. This is actually a business decision.
Being
Like
smart.
for
I'm in.
NVIDIA, our business needs us to know about AI very deeply, and so the amount of investment that is justified to carry on NVIDIA's ongoing business, I think, is large. And so that's job number one for Nemotron. Now, job number two for Nemotron is to support the ecosystem more broadly outside of NVIDIA. NVIDIA has a special position in the AI landscape. Of all of the big AI companies, I think we're the one that works with the most other companies. We support every company, small and large, AI native company to old established enterprise. We work with hyperscalers, we work with tiny little startups, we work with countries around the world. So we have this unique position, and I think also a unique responsibility, and maybe also a unique opportunity, that whenever AI is able to grow in any sort of direction, in any capability, then that's an opportunity for us to grow our business. Obviously, it's not automatic, right? The AI market is diverse, and it's getting more diverse, and it should be, because it's the most important market in the history of humanity. So we acknowledge that, and at the same time, we know that it's in our interest to develop the AI ecosystem. The more people that are building, inventing, and deploying AI, the more opportunity that we have as a company. So that's job number two for Nemotron.
Yeah, I really appreciate you saying it so directly because it's like I launched this thing, the Atom Project last summer, which is trying to get more investment in the US open models. And I was like, the only company that has an obvious business model for open models is something like NVIDIA, where you need to make sure that the open models and the research ecosystem plays nicely on CUDA, because then you're going to be able to be you're so many steps closer to research that's happening. If not, like if it like
Yeah.
there's such an advantage to have research happen mostly on GPUs relative to AMD or anything like this. So
Well, we're not thinking about how to prevent competition. We welcome competition. There's lots of competition. There should be more competition in this space, but we are very self-interested in staying engaged with the community. It's very important. CUDA, not many people remember this because it happened so long ago, but CUDA started out with a lot of outreach from NVIDIA to the academic and industrial community saying, hey, we have this new way of doing computing. We'd love to see what you can do with it. In fact, I started using CUDA in 2006 when I was a grad student at Berkeley because David Kirk, who was the chief scientist of NVIDIA at the time, came over to Berkeley and said, hey, we just released this new GPU and it has this new programming model called CUDA. You should give it a try. And I was at the time I was working on machine learning on FPGAs, and I had been working on this one particular piece of support vector machine training on the FPGA, and I decided to take that little piece and write it in CUDA, and it took me like 15 minutes, and then I ran it, and it was like 200 times faster than my single-threaded CPU code, and I was like, whoa, that was way easier than what I was doing before. I'm just gonna go do that, right? So like my own personal involvement with CUDA and NVIDIA came about because of this outreach that NVIDIA conducted right from the beginning of CUDA. Of course, that led to a lot of great things for NVIDIA, including AlexNet, which was another academic project, where Alex Krzyzewski and Ilya Sutskever were thinking about how do we train larger neural networks on more data. We're going to go write a bunch of GPU code that uses the GPU in a kind of new and clever way so that we can train a better image classification model. And, that had such astonishing results. It kicked off the deep learning era for the whole community. And again, not something that could have been done top down. That was a very much a result of NVIDIA supporting open development and research in parallel computing and artificial intelligence. And so we remember that, and we're thinking about in 2026, what does it look like to help, the Alex Krzyzewski of the future, who's a grad student in a lab somewhere, invent the next technology that changes the world. It seems really difficult to do that without something like Nemotron or the other openly developed AI projects out there. Yeah, I also want to say in regards to this, Nemotron is not trying to be the only project out there. We're part of the community. We love other people doing great work in openly developed AI. We learn from things that other people do. So we're trying to support the community because it's in our interest, but we're very happy to see other people contributing as well.
yeah, I mean, I can transition to something I wanted to ask about is like I see multiple ways 2025 Nemotron, but I don't want to use the word maturing because I want to ask you about how it feels in the org, but just like the output reached levels that were more noticed by the community and people building with models. And there's a lot of ways that that can happen. But one of them is like in my niche community, I've been using Nemotron datasets a lot. Like when we redo our post-training recipe, one of the only people we look at is like, okay, NVIDIA Nemotron has released a lot of high quality, openly licensed post-training data. This year, you also started releasing some pre-training data, which among AITU got a lot of notice. Like, what is that? Is that like a distinct shift within Nemotron? Is that something that you've wanted to do for a while and finally just did? But it's because it's like, it is just like a 0 to 1 moment where releasing pre-training data comes with legal risk for any company, but so few people do it. Where on my side of the world, it's like, pretty easy to normally say what the best pre-training data set is. And it had for a long time oscillated between like Hugging Face, AI2, DCLM, and there was like literally only two or three options. So in terms of fundamental research, like I think that's a big step from an org to support the community and take on some risk. So if you have any story you can tell, and or just say like I appreciate it. That's all I got.
Well, yeah, I mean, so I think it'd be great if more people could understand that Nemotron is not just a model, right? Like what we're trying to do with Nemotron is to support openly developed AI because, again, that's our big opportunity, right? Now, there's a lot of organizations that are incentivized to build a model, and the model is maybe the thing that runs their business, right? But at NVIDIA, the model's not the thing that runs our business, it's the systems. So when we're thinking about how do we support the ecosystem, it's clear to us that the ecosystem needs more than just a model. There's a lot of models out there already, you know? And of course, we want Nemotron to be awesome, but you know, if Nemotron can convince other people to work on AI because of a data set or a technique, you know, we're trying to be very open with all of the things we learn, you know, including, I mean, we do a lot of expensive experiments in order to figure out how to do blending for our data sets or to figure out, you know, optimize our settings and, you know, these sorts of things. Um, we're very happy for other people to pick that up and run with it if it's useful to them, you know, and so that makes Nemotron a different kind of AI effort. Of course, there is a model component, and that's a tangible thing, and it's easy to focus on that. But we see Nemotron as you know, an effort that includes models, but also includes data sets, techniques, all of the research that goes into Nemotron. And again, we're a unique kind of AI organization because of the way that we work with AI companies around the industry, and because of the way that our business works, we can afford to be more open with some of these things than maybe some other organizations could be. Now, to your question about like, does it take some courage in order to be open? Yeah, absolutely, it does. And you know, I think there's been one of the things that's happened in 2025 is that there's been an evolving understanding within NVIDIA about the benefits of openness, and that has really enabled the company to make some investments that perhaps it was a little gun shy to make in the past. And so that's really encouraging for me. It's something that I've you know, advocated for a while, and so it's great to see the company kind of lining up behind it. I also, you know, to your point about like 2025 being a year where Nemotron really made some strides, I want to say thank you for noticing that, and then maybe tell you a little bit about how that happened because I think it's instructive for me about how I think the work is going to go forward in the future. So, you know, NVIDIA is a very decentralized company with a lot of volunteers. You know, everybody that works at NVIDIA is a volunteer. And what do I mean by that? Well, I mean, look, the industry is moving quick. You know, people can always move from one job to the next. So the way that we think about the work that we do is like it's very decentralized. It's very much let smart people figure out what they should be doing and then kind of self-organize. Now, one of the challenges of self-organization in a field that's moving quickly is that sometimes a whole bunch of people decide to do similar kind of overlapping things, but aren't really coordinated. And that's okay at the beginning because, you know, in a place like NVIDIA, it's just great to have some energy. It took us a while, I think, as a company to figure out that Nemotron was better together. That rather than having like this group has a model and that group has a data set and like, you know, then we end up publishing papers that kind of you know, don't really acknowledge each other and aren't really coordinated. And then of course, along with that, we need to have K times the GPUs, where K is the number of independent efforts. We realized that, you know, building AI, you really do need to figure out how to collaborate. The the AI efforts that are built from teams of people focused on the overall effort succeeding rather than their own particular piece of the project succeeding, those are the ones that, you know, really change the world. And of course, NVIDIA works that way for the systems that we build, right? So like the people working on the memory controller on the GPU know that they also have to work with the people working on the SM that does the math, right? Like you can't make a GPU where it's just like, well, we've got an awesome memory controller if the math doesn't work, right? It all has to kind of work together. And so that coordination, I think, in the field of AI, it took us a little bit longer to do, maybe than you could imagine that it could have. And I think that slowed the progress for Nemotron. So I give a lot of credit to the Nemotron team for realizing over the past, I don't know, year and a half or so that it was really time to join up and build one thing and make it awesome and deeply understand that the success of the Nemotron project was more important than the success of any individual piece of that project. And the reason why I'm telling you all of this is because I think that's actually true more broadly than just inside NVIDIA. And I think it's difficult. Researchers like those of us with PhDs, for example, we are taught how to be independent, and how to build up our Google Scholar profile. And there's like an incentive to go ahead and focus on that. And a lot of successful academics and people, researchers, they manage to push that pretty far and get some pretty amazing results. But I do believe that in 2020, in the 2020s, that the best research is done as part of a larger team. So how do we figure out how to work together? How do we figure out how to put the success of the team first? That is a thing that is challenging to do, but if we can achieve it, I think yields significant results. And to the extent that we made progress in that part of the organization, I think we also saw progress in the technology. And that gives me great hope for 2026 for Nemotron because the way the team is working together, I think, is pretty extraordinary. There's just an enormous number of brilliant people that have decided that they're going to volunteer to make Nemotron awesome, and we're starting to see some pretty great things come together.
I agree with everything you said. Do you have any advice for making the orgs come together? I think we've seen big. Wait, I see there's two classes of AI companies right now. One is startup does everything and you have a model in 6 months, but you're building from zero and everybody agrees when they start that they do this. And then you have Google's famous long-winded reorgs, which they actually eventually got right. Like they got it very right with what's going on with Gemini and Google
Yeah.
DeepMind right now. And it's like, do you have any advice on doing this? I think like I'm AI too also advocating for this, but it's very hard. I think
It's
personally, it's like I mean, I'm a special case because I'm also visible, where it's very easy for me to turn internet activity into like reputation points because of algorithms and size, but it's very hard to do bottom up technical work and get all of this and get all the culture alignment. So, do you have any advice on actually like what works in this domain?
you know, what's worked for us is invitation and not control. So one way that like for a while I kind of wanted to try to implement was like nobody gets to publish any papers in AI unless they're clearly part of Nemotron. So this is kind of a top down, like we're gonna make you do it, right? Uh, I came to the realization that, which we never implemented this, by the way, but I came to realization that this was a bad idea because it would just breed resentment. And, NVIDIA is a company of volunteers. Everybody here is a volunteer. So what we need to do is create the conditions by which it makes sense for people to volunteer to be part of Nemotron. And so the way that we went about doing that, first of all, it involved like some top level agreements between me and some of the other leaders of Nemotron, for example, John Cohen, Carrie Brisky. I work very, very closely with the two of them. And, that hadn't always been the case. Like we kind of had all come to this place independently. But we realized like Nemotron better together, all three of us. And then we started telling our teams that, we really think Nemotron is going to be better together. So that top-down alignment, I think, was really helpful. We weren't telling people exactly what to do, but we were just sending a constant message like, Nemotron's better together. And then we built some structures that facilitated collaboration. So in the past, decisions in the Nemotron project tended to be made in kind of an opaque way. And the reason for that is just, it's hard to tell everybody about the middle of the sausage making process. It's like messy and difficult. And so like, it's natural. Like researchers, we're used to doing this, right? It's a fait accompli. Like, here's my ICML paper. And like, the fact that you spent like 2 years failing at that task before you finally succeeded, and then you tied a bow around it and gave it to the ICML committee, you don't really talk about that, right? And so it's difficult for researchers to be open about the middle of the process of research. There's a lot of failure, and it's hard for people to feel like they're not looking amazing. But what we decided to do is we structured the project with there's about 20 different areas for the project. Each of them has a clear leader, what we call a pilot in command. The job of the pilot in command is to land the airplane. You just want the airplane to land. Okay, so if you're landing an airplane, there might be multiple pilots on board, but only one of them is going to land the airplane at any time, right? Because it would be chaos if two of them tried to land at the same time. People would die. So this is not a committee structure. It is a delineated responsibility structure. And the purpose of that pilot in command for each of these sections is to gather together all the best ideas, help the group of people that are interested in working on that space to come up with data-driven answers to what we should do, what technical decisions we should make, and then document that, in a way that other people can review. The thing that's been really great about that is that it is inviting to people, because when they see like, okay, here's the group of volunteers that are working on this area of Nemotron, and then they want to contribute, it's much clearer about how they could go about doing that. And it's also clearer what the group needs, because these meetings are being held in the open, and we actually have a website where all of the ideas are submitted. They each get like a unique identifier, and then they get engaged with, the pick is trying to understand what the implications are, what kinds of experiments need to be run in order to prove or disprove the idea. How do we do what I call integration studies? Integration studies are so key for bringing researchers together, and they're so opposite of what we were taught when we're learning how to do ablations as a graduate student. Rather than like isolating the particular contribution of one idea, integration studies are about putting 100 ideas together and seeing if they're better than what we had before. So this kind of thing, doing that in a structured way, in an open way internally, has then made it possible for more people to volunteer. And that has then generally raised the rigor of the experiments, and also I think the outcome of the work.
Yeah, this is great. I think that over the last few years, there's been more consensus on things that work for research. And I think that we also do integration tests very regularly of like, is this feature going to land for the model? And that's kind of it's a nice mirror to ablations, where we know research is changing so much. There's a lot of turmoil in the academic research community, and it's nice to have things that are tangible as ways that are a little bit different when you're doing these large scale projects. So people that understand, like, you still need to do ablations,
Yep.
but then it needs to survive like an additional test in order to land into the model. So it's like an additional type of work that needs to be done. And I just like to have words to describe what is actually happening. I think
Yep.
on the Nemotron 3 Nano front, I do a lot of analysis on just looking at basic adoption metrics. And Nemotron, we created this, what we call like a relative adoption metric, which is essentially looking at downloads over time for models, because it's easy to know which models have a ton of downloads that were released a while ago, but to like look at the trajectory of downloads changing over time. This is a mouthful. It's kind of an aside, but like Nemotron Nano 3 was in the 30B size range, like on track to be one of the top 10 models downloaded of all time. The point that I bring this up, other than to just flatter you, is like, do you think last mile adoption takes a substantial amount of work other than making like a very functional model? Or does adoption, like, do you need to like change the recipe that you're making and put a lot of focus and evaluation and like change this over time so that you actually get people to really use the models rather than like, oh, the benchmarks are good, look at NVIDIA flying high.
Right. Yeah, I mean, wow, it has taken the whole company coming together in order to make Nano V3 uh, have more of an impact than the models that we released before. And uh, there's so many different aspects to that. Obviously, there's a lot of technical aspects, which, frankly, I think we have more work to do. So, like, making sure that on day zero, when we release something, that the quantizations, all the quantizations, the best quantizations are out there, that the speed on all of the important inference frameworks is out there, that it runs on all of the edge devices that we care about flawlessly, that the install experience is great. This kind of work is extraordinarily important because it's a crowded world. There's so many different things that people could choose to work with, and any amount of friction that gets in the way of people even evaluating something that you do is going to blunt the results, no matter how good that technology is. I don't think that we're amazing at this yet, so this is something that I anticipate we're going to see a lot more investment in as more people at NVIDIA from all over the company, from marketing, from developer relations, from software engineering, as we all come together in support of this effort. So it does take an enormous amount of work. And then, something that I'm particularly interested in is, how do we work in a new way, sort of engage with the community to make future Nemotron models even stronger. You know, uh, if the only things that we were to optimize for with a Nemotron model would be kind of academic benchmarks that are, highly cited, um, it's likely the case that the model wouldn't be general enough to really be useful. And so what we're trying to build is a technology that other people can extend and deploy. And that means we need to have like other ways of understanding the strength of a model besides, a handful of academic benchmarks. I think we have a lot of room to grow here. I'm hoping over time that we develop the muscle of being able to engage with the community and learn from them. Like, okay, this particular thing that I tried to do with Nemotron, it didn't work. It did this other thing that, I wasn't expecting. It was wrong. Well, that can become feedback that then is used to make the next version better. I think we've got a lot of work to do in that regard.
Do you think there's any magic to it? I'm blown away by how successful OpenAI's two open source models are. Like, yes, they're obviously the number one name brand in AI, but on the same metric that I see you guys like overperforming like what I would expect, I'm like, wow, like great job, NVIDIA. They're like totally off the charts, like on track to like beat Llama's like most downloaded numbers ever with these two GPT OSS models. And I feel like what they like even on release, they had hiccups where people were pretty negative on it. But for whatever reason, it has just like people figured it out and it just clicked. And it's just like for a company to say so little about it, like Meta put so much effort into Llama being adopted, and you obviously are
Yeah.
putting a lot of effort into this. Like I'm just like, did OpenAI just crack the code, or is there sometimes a bit of luck?
Well, I don't think I don't think about OpenAI as a lucky company. I think of them
Yeah.
as a visionary company that works incredibly hard, and I think their success is well deserved. I love the GPT OSS models. Definitely they're an inspiration for us here at Nemotron, and yeah. So I think um, OpenAI also has like some other ways of engaging with the community just because of the large number of people that use their services. And that helps them learn things about what are people trying to do with AI that then they can address when they're building models. And, obviously, people talk about that as a flywheel. I think that's really interesting and really important. NVIDIA is never going to have the same kind of flywheel as OpenAI does. We're not trying to build a service like ChatGPT. What we're trying to do is help the ecosystem, you know, be strong and enduring. We think that it's important for there to be this openly developed AI ecosystem, and also we're trying to build our next generation of systems. And so we have our own reasons for doing this, but we're not ever going to have the same exact user base or flywheel that OpenAI does. On the other hand, you know, we are able to work with institutions around the world in our own way that I think offers us different opportunities, and hopefully that helps us make things that are useful too.
Yeah, this makes me realize I'm having a lot of conversations on there are many open model efforts, especially even among people that are fully open. And it's like, how do we better coordinate? So especially at the smaller scale, it's like AI2 and Hugging Face, so they're not big teams. Like, how do we make sure we're not doing the same data project at the same exact thing at the same time? And it's like, I wonder if there's opportunities for open companies like LM Arena has historically released a lot of user data to like better help us close this kind of what are people using models for flywheel. And but it's very hard to build cross organizational model improvement pipelines is something that I think models become pretty vertical in terms of somebody at NVIDIA getting the feedback and the model making better. So that's what would be something I would like to see this year, but I don't have ideas for doing it well.
Yeah. You know, at NVIDIA, we have a tradition of working really closely with, you know, organizations that use our technology. Um, uh, and, you know, we have teams of engineers that their job is to enable success for our customers. In fact, there's more people at NVIDIA that care about the success of people outside of NVIDIA than I feel like sometimes there are people that care about the success of things inside NVIDIA. So like sometimes I'm like, hey, could we use a little bit of that energy to support Nemotron? And the answer is yes, and NVIDIA is doing that. But uh, I think as Nemotron matures, we're going to find that you know, the organizations that work with NVIDIA to make Nemotron awesome for their business, for their use case, are going to have a say in how Nemotron evolves, and hopefully that helps Nemotron address their needs.
Yeah, a basic question. How many people, like how many employees does it take to build all the different versions of Nemotron? I haven't brought this up because you also have other great types of models. I think our like open model analyst Florian is obsessed with the parakeet model because
Oh
he's
yeah,
much
yeah,
faster at typing and he's much faster at speaking than typing. So there's a lot of other, I don't know, I don't have the full list of other NVIDIA models off the top of my head, but you're releasing a lot of varieties of models. So I think it's a bit of a there's more context to my original question, which is I think about language models because I just think of AI's progress is going to continue to go very fast, so I focus as that as the engine. But it's like how many people is putting this kind of movement into place?
yeah. Well, it's hard to know exactly, and as I said, NVIDIA is a company of volunteers, but um, and also these days things are changing, right? Like so, the Parakeet team, which is an excellent team, by the way, um, they I would say a year ago wouldn't have really considered themselves so much part of the core Nemotron effort, but these days they absolutely are, for the obvious reason that, you know, LLMs these days need to be able to consume all sorts of data, right, including audio data. And so, um, uh, you know, as the as the characteristics, the capabilities of Nemotron models expand, obviously the number of people contributing is going to expand. I'd say right now there's about 500 people that are working pretty much full time on Nemotron technologies in different ways. This is everything from numerics, quantization recipes to speech recognition or image understanding, or you know, pre-training, post-training RL systems, inference software. You know, there's a whole bunch of different dimensions, right? So I'd say it's about 500 people, but also we're having our Nemotron all hands meeting this week, and so I took a look to see how many people were invited to that all hands meeting, and it was about 2,000. So those are people around the company that are interested in working with Nemotron and either expanding its capabilities or helping its adoption. And so I think the number is somewhere in between, and it's hopefully going to keep growing as Nemotron matures.
Yeah, I mean, that's one of the greatest attestations to what you were saying is like if the interest inside the company is 4 times as big as the people doing it, you're gonna keep scaling up, it seems. People are gonna
Hope
find
so.
ways to help.
Yeah.
Um, One of the other things I'm interested in, I don't know, like on the point of 500, it's like it sounds like a lot of people, but with how many things you have going on, it seems also very few. Because I'm transitioning to thinking about the longstanding like open source software that you've had for Nemo and I think Megatron, and it's like they've been around for a long time. I think Megatron has gone through many eras. I have a note here. It's like these softwares have been going on since like 2019 in some form, and
Yes. Well, publicly, we made
yeah.
our first public release in 2019, but we started earlier.
And
Yeah.
it's something that I've found is that when I started doing like language models, so it's a late bloomer, and we'll transition to some career talk in a few minutes at Hugging Face. Like Megatron had like a bad rap as being very hard to use, but now like 3 years later, I hear from anyone that's founding a new language modeling startup, they're like, just use Megatron. Uh, like, do you pick up on things like this? Is it just like
Well,
random?
we
But
work
it's like,
really hard on it. We're trying really hard to make Megatron easier to use. It's difficult. Megatron is a complicated piece of technology. And, when we originally started Megatron, the point was to show the community that you could make state-of-the-art large transformer language models with NVIDIA. I don't know if you recall, but um, there was some assertions by some other companies back in 2017 when the transformer was invented that they could only be made without NVIDIA. In fact, there were statements to that effect on official blog posts, which I think got redacted later on. But it was important for NVIDIA to show up and say, we love language models, we love transformers. Let's see what we could do, if we partitioned the work properly on lots of GPUs with an amazing interconnect, what kinds of models could we train? And so that's where the Megatron project started. I actually came up with the name Megatron. One of my proudest moments, I suppose, I was thinking about it. I was like, this is a really big transformer. What's the biggest and baddest transformer? Oh, it's Megatron. So that's, where the name came from. But you'll think about that. That had nothing to do with usability, right? Like I wasn't thinking about like how do we make a platform that's really easy for other people to use. I was just trying to show the world that like NVIDIA systems could be awesome for transformers. That was my goal. Over the years, it has evolved. We have a lot more people trying to use Megatron. We got a lot of complaints about how hard it was to use. And then we did a lot of work to try to improve the software engineering around Megatron. These days, Megatron software engineering is actually shared between about 4 different teams at NVIDIA. And we have to coordinate that work very closely. That has also not been easy. There has been times when, you know, people wanted to fork Megatron, and then there were times when we like had to bring it back together. And it's like, look, I know forking things is always tempting, but look, better together. It's better for all of us to keep working together. And so I feel like Megatron, and especially Megatron Core, which is like a subset of Megatron that's like especially protected, and we try to put more software engineering into that, that has gotten dramatically better since we started paying more attention to it as a company. Um, are we done yet? No, there's a lot more
Uh,
work.
a basic question is Megatron or Megatron Core like this is what Nemotron is trained on, and
Yes.
it's also something that many of the hottest like AI startups are training their models on. I would guess that there's nothing else that does that, so that could summarize why it's so hard.
Well, there's a lot of other great frameworks out there. Megatron's not the only one, and we're happy about that. NVIDIA doesn't need to control this space. What we do want to do is make sure that we're putting our products forward in the best light. And it's a challenging problem. We've got so many things going on with precision and the networking. Like those questions, like the software is so complicated. These days, we're pre-training our Nemotron 3 Super and Ultra models using FP4. which is a thing that hasn't been done publicly anyway, and something that we're pretty excited about because our GPUs have really awesome FP4 throughput. But obviously, the numerical challenges of like trying to train a state-of-the-art language model using 4 bits is non-trivial. So like, all of that work has to go into Megatron, into Transformer Engine, which is another open source project that Megatron relies on, and coordinating all of that, making sure that we can actually deliver the benefits of NVIDIA systems to people that are trying to make state-of-the-art models. That's really, really important to us. And of the 500 or so people working on Megatron, like a pretty good fraction, or on Nemotron, a pretty good fraction of them are working on these kinds of systems issues, right? Because NVIDIA, at its core, is a systems company. And Nemotron's first job really is about systems, and so we care deeply about that.
Yeah. I mean, from my perspective, I was at Hugging Face before AI2, and Hugging Face is like the best company at doing public work. But also, and switching to AI2 and focusing on like, we're focused on the output artifact the most, seeing the different type, like, it's such a different type of work going from you're trying to build a tool that's good for training models to build a tool that's good for everybody else in whatever heck use case they are.
It's
So I think
different, yeah,
to
different work.
do both is like I'm happy that AI2's repos aren't that popular in terms of open source adoption because like, we can't handle it. We just can't. It's like so hard because it's people. It's like it ends up being researchers that are supporting it, and we don't have the ability to scale the organization structure. So I just like that's a very fun turnaround for me to think of all these things happening at once.
Yeah. Well, thanks for noticing we're putting effort in. I would say Megatron is still not nearly as user friendly as Hugging Face libraries. Hugging
Yeah.
Face libraries are legendary, and I admire the work they've done to make the community so productive. People, are able to get so much research done thanks to the work that Hugging Face has put into their library. So, my hat's off to them as well.
Yeah, one of my hot takes, you don't have to reply, is that Hugging Face and NVIDIA have been very good partners. And it's like
Oh,
bringing that Hugging
absolutely.
Face culture to the NVIDIA stuff would be so good. It's just so hard. So I don't know how that would work,
We're
but
trying, and uh, it is challenging. NVIDIA is always a company that um, is going to prioritize speed, like hardware speed, above really anything else because that's like who we are. I am always trying to make the case that developer speed is important too, right? It's like there's different ways of thinking about speed. Um, and it is definitely the case that a lot of NVIDIA's software is so cumbersome to use that people can't get the actual hardware speed as fast as it should be because they just give up. They just don't even figure out how to use that. So I think NVIDIA is making strides there. I think the company is understanding more deeply how important developer experience is, and I hope we continue to push that so that the benefits of all of the systems technology that NVIDIA works so hard on can be more widely used. But at the same time, there is going to be a tension between those things. It's not going to go away, and to a certain extent, I think that's just life on planet Earth.
it is. I think you're doing a good job. And I'm going to kind of shift gears in this interview. So in becoming more back in language, in becoming a person that works in language models, I've seen your name more and more times. Like Bryan Catanzaro, like where have I seen this? And then I went and did the research of the Berkeley PhD in. It says April of 2021. You gave a Berkeley EECS colloquium titled "Applications of Deep Learning and Graphics, Conversational AI, and Systems Design." I'm not even going to posit that I actually went, but that's definitely where I remembered the name from in grad school. And we both have backgrounds that aren't traditionally in AI and end up working in language models. I just wanted to like, what have you learned from your path through NVIDIA into what like people should be thinking about with AI or open models today? This could be career reflections, like like technical reflections. I just think that there are actually a lot of people that come from all over the like STEM field to work in AI. So giving it space
Sure.
to think about is useful, even if it's just like it was the big problem and I wanted to go solve it.
Well, I think you know I've had a lot of opportunity and a lot of luck in my career. I think in hindsight, it seems like an extraordinarily lucky thing that, I did my first internship at NVIDIA in 2008, and I was like building machine learning models on the GPU, and I went to NVIDIA, and nobody else was really doing that. And I was like, hey, like we should have more people doing machine learning on the GPU. I think this could be an opportunity. And it took a few years for me to make any headway. NVIDIA didn't really want to listen to me. I was a brand new PhD. I was in the research organization, which is very independent, but sometimes struggles to change the way that the bigger company thinks about things. And yet I just had this conviction. I just was following my heart about what do I think is going to be important? What do I think could really change the world? And um, that has been, I think, the thread that has taken me through my whole career, is that I'm constantly trying to refine my beliefs about what matters, and then um, hold to them. And that, I don't know how helpful it is to say that, but I feel like sometimes people, tend to follow the whatever the thing is that people are talking about on Twitter. And like I've done a lot of unpopular things during my career because I believed in them. I remember I published my first paper in 2008 on at ICML on training support vector machines on the GPU, and I actually had somebody at the conference. It was in Helsinki. At dinner, we were all telling each other what we're doing, and I was like, yeah, I want to help people train bigger models on bigger data sets with GPUs, and I had a couple of people just say, well, why are you here at ICML? That just doesn't really feel like a good thing for us. And in 2008, ICML was mainly about new mathematical frameworks for thinking about data. And, maybe if you trained a model at all, you would train one on your laptop. That was the state of machine learning in 2008. So for somebody to come in and say, I think I want to focus on like parallel computing, new kinds of hardware for machine learning, programming frameworks for machine learning, so that more people can try inventing new models on complicated machines with a lot more compute throughput on bigger data sets. That was like an unpopular thing. At least it felt very unpopular. I felt very marginalized at the time by the community, but I believed in it. I just felt like, look, technology, like I have this sense of like, where do I think technology is going? I knew that traditional computing was running out of steam. I had done a few internships at Intel, and I was trying to help Intel make processors that ran at like 10 gigahertz back in 2001. And it was like clear that they were running into a wall. And I was thinking, okay, so if the compute hardware is going to have to be different, it's going to be more restricted. It's not going to be able to be so general purpose in order to get speed. What kinds of applications are going to have like an infinite need for more computing? And I thought, well, machine learning and AI, that could really change the world if it ever actually worked. But back then it kind of worked inside of Google. Outside of Google, it kind of didn't work. And so I had kind of these signals, like it was possible, but it was hard. It was a little weird. It was a little niche. I was a little bit caught in between different fields, like the systems people didn't think I was systems enough, and the machine learning people didn't think I was machine learning enough. But I believed in what I was doing, and I found a way to keep following that belief. And ultimately, it was very rewarding when all of a sudden NVIDIA decided, hey, deep learning is changing the world. What do we know about deep learning? And then it was like, oh, well, Bryan's been doing that for several years, and he's written some libraries that we could turn into a product. Let's go do that. And, so that all happened really quickly after many years of nothing happening, and that was really obviously an amazing opportunity for me. Um, Another thing that was important to me, I left NVIDIA in 2014 to go work at the Silicon Valley AI lab at Baidu with a group of really talented people, including Andrew Ng and Dario Amodei and Auni Hanoun and Adam Coates. And this was a really once in a lifetime opportunity, I think, for me to learn some things that would have been hard for me to learn on my own. I felt at the time at NVIDIA that although I had this great opportunity to help NVIDIA become an AI company, and I was doing that, and I was succeeding at that back in 2013, 2014. I also felt like um, I really wanted to learn from a broader community of people applying machine learning and AI to solve really important business problems. And going to work at Baidu really gave me that chance. And I was there for a couple years, learned a ton. Very grateful to the team there, especially to Andrew Ng, who encouraged me to join with him on that. And then, I ran into limits of what I could do in California, working for a Chinese company. I was thinking about, what should I do next? And Jensen asked me to come back and build an applied research lab at NVIDIA in 2016. I wasn't sure like if that was a good idea. I thought NVIDIA's already grown so much. The years from 2014 to 2016, NVIDIA actually grew a lot. These days you look back at it and you're like, it was still really tiny. But back then I was like, I don't know, maybe NVIDIA's already tapped out. I don't know if you recall, in 2016 there was already like 10 different companies making GPU competitors, right? The TPU had already been out for a while. It wasn't clear that NVIDIA was going to become as large as it has. But I believed in the opportunity. I believed in the people. One of the things I loved about NVIDIA was that it's a very stable organization. So Jensen, he's been running it since he founded it in 1993. My boss, Jonah Albin, who's an absolutely extraordinary person, has been here for quite a long time, almost since the very beginning of NVIDIA. And these people, a lot of the leadership at NVIDIA, they love the work. Their heart is in the work. Jensen and Jonah and many other leaders at NVIDIA, they don't need to be doing this, right? They have earned the right to go sit on a beach and drink Mai Tais all day, but their heart is in the work, and they work incredibly hard. I feel like if there was an Olympics for email, Jensen would get the gold medal. It's unfathomable to me, like how much information he's able to process. And it's a skill that he's built up over a long time running this company, but it's also a reflection of his commitment to the work. And I felt like working at a place where we've got this very stable organization that loves the work, that really wants to change the world. Why does Jensen get up in the morning? Well, this is his chance to do something meaningful. I thought, associating with these people, I could do worse. I think I could learn from this as well. And so I came to NVIDIA, and back then it was really hard to explain to people why I was trying to build an AI lab inside of NVIDIA. At the time, NVIDIA wasn't doing very much AI, and so I had to kind of develop a vision for that and then explain it to people. That's ended up being a really good idea for me as well. The lab, I think, has really helped NVIDIA. Megatron, I think, has really shown the industry like how valuable NVIDIA systems can be for language modeling, which is awesome. DLSS, I'm continuing to push DLSS forward. Very excited about making graphics, more efficient with AI. These days, 15 out of every 16 pixels a gamer sees are rendered by AI models that, my team developed. And that then makes the GPU 10 times more power efficient. This is a really exciting, thing for me to be involved with, something that I've, dreamed about for years. So that's the kind of thing that continues to push me forward, is that I have strong beliefs about what I think is possible, where I think technology is going, and I'm willing to do things that are weird and unpopular, but basically following my convictions. I'm very much always thinking about the people I'm working with, the tribe. I think tribes matter enormously. If I so back when I was a grad student, I was working on programming models for machine learning. I joined the Python tribe. There are other people that were in the Scala tribe. And the people that did their work in the Scala tribe trying to make programming models for machine learning in like 2010, that work, although a lot of it was technically excellent, didn't matter to the community as much as the people who were in the Python tribe. It ended up, it kind of sucks sometimes that the world is tribal like this, but it's just the case, that like the people that you work with, the community that you work with, has a big impact on the problems you think about, and then the impact that your work has. So I think a lot about the people and the tribes that I'm collaborating with or that I'm part of, and that's kind of been the thread that has carried me through my career.
Yeah, thanks for sharing this full arc. I think you've said things that I tell people about in different languages. And the first one, the early days, it seems like there can be space in between fields where two fields will have their way of describing things, but both of them are probably incomplete and there can be space there, which is a lot of what I was doing transitioning from novel robots to model-based RL, where I like didn't sit in bare in the actual AI lab, but I started doing AI with my like total electrical engineering friends. And then the second thing is like I wholeheartedly recommend this to people is like choose your work based on the people and people that sincerely are in it for
Yeah.
the what they want to do. And a
And
lot of
follow
it
your
honestly,
beliefs, think about it. What do you believe in? And
yeah.
it's okay to change your mind, but like figure out what is it that you believe in. Ask yourself every day, do I still believe in that? If I do, what next? If I don't, well, what do I believe in? That's been really important to me. I think too many people end up kind of just following trends. That's not usually helpful because the trends are too late. So if you want to change the world, you need to be ahead of the trends, and you need to know, trends. I don't think trends in computing are just fashion. I think there's truth that drives those trends. Not always, but often. It's just there's kind of an inevitable force of gravity. It just can be really hard to parse out the noise, and figure out what is the truth that is going to push the industry forward, and how can you push that with it. If you can join with that, you can accomplish great things.
Yeah, I agree. I think in building language models, it's like you want to build a model that the community wants in 6 months. I think if you're building a model to compete with the models that are already out, you're not going to keep up. And I think that's like, what is the right thing is building open language models in 6 months. And like, where do you need to try to steer things is one of the hardest problems that I think about. So if you want to close with any predictions where you see like open models, like if you're going to be here at the end of 2026, if there's anything you think will be far more obvious than it is today, or any bets that you want to make, I think it's kind of a good place to wrap.
Well, predictions are always hard, and I don't feel like I'm very good at making predictions, but I feel like I am good at identifying what I believe in. And what I believe in right now is that compute remains one of the fundamental challenges behind AI. It has been that way for a very long time, and I think it continues to be. I think as we find new ways to apply compute to AI, we discover new forms of scaling laws that help AI become more useful, and therefore it becomes more widespread. So I'm going to keep thinking about compute. I continue to believe that the fastest, that the way to think about AI is not just in terms of absolute intelligence, but rather intelligence per second. There's some sort of normalization in there that relates to how fast a model can think, how fast a model can be trained, um, or post-trained. That models that kind of incorporate this compute acceleration characteristic where they're thinking about intelligence per unit time, those are going to end up winning because they end up getting trained on more data. They end up getting post-trained with more cycles. They end up with more iterations during thinking when they're deployed. And of course, if they happen to fit the hardware really well, whatever hardware that is, then that can have a pretty non-trivial effect on the intelligence as well. So that's something that I really believe in. I really believe in AI as an infrastructure. There's different ways of thinking about AI. Um, I think some people believe AI is um, uh, more like the singularity, like once AGI has been declared, then the whole world is different forever, and all humans have lost their jobs. And there's a lot of things about AI that people believe that I personally don't believe. I believe, first of all, that intelligence is very multifaceted, that it is not easy to pin down, that as soon as we try to pin down intelligence, we find that there's very many more forms of intelligence that aren't covered by that. So, for example, a model that achieves gold medal status on the International Math Olympiad, that's an extraordinary achievement, but it doesn't make me have no job, right? Like I'm actually not solving math problems all day, even though like having the ability to solve math problems is clearly very useful. And it's also the case that intelligence is kind of like a potential energy. It's not a kinetic energy, right? In order to transform intelligence into kinetic energy, it needs to have a platform. It needs to be applied in the proper way. And that is why I believe in open models and openly developed and deployed intelligence. I believe every company, every organization has secrets that only they know. They have special data, they have special ways of thinking about their problems, their customers, their solutions, and they're going to know how to apply AI better than anyone else. And so AI as infrastructure that transforms companies, turbocharges them, allows them to take the things they know and multiply their impact. That's something that I believe in more than AI as an event that one day when it happens makes everyone obsolete. I just don't believe in that. I often joke that like if, for example, the CEO were to retire at some point and we needed to find a replacement, handing out an IQ test or asking, who has the highest SAT score, that would not be a very good way of finding a replacement. Intelligence is just far too complex for that. And so, so these beliefs, you can disagree with me about anything that I just said. I'm not offended by that. I have a lot of friends that do. But I'm asking myself, well, if I believe that intelligence has these characteristics and that AI is going to change the world by turbocharging institutions that exist, and also creating new applications that we haven't even dreamed of yet, rather than replacing all humans, then how do I go about building that? And so that's kind of the direction that I'm on right now.
Yeah, I love it. I agree. I agree that we're entering an interesting area where the open models are taking so many different shapes and sizes and have so many different strengths and trade-offs that there can start to be interesting interplay as an ecosystem where there's just so many different things going on. And I think I like your idea of potential energy, and you have to build things that are kind of unclear of what it's like. You have to build the energy in a way, and you don't really know what the goal is, but you have to try to build these good models. So I appreciate it, and
Yeah, and then let people apply it. Let them make the kinetic energy happen.
I agree. Thanks for coming on.
Thanks so much for inviting me. It's been a great conversation.
Yeah.